In this video, I'm going to make a few more examples about functions. We already know the definition of functions. We define that as the function is a relation between input and output. I made the example that we can assume function is a factory. For example, the factory that gets input like 1, the output is 5, 2, we get 3, and like a 9, we get 11. So in this example, you can see the input is 1, 2, 9, and output is 5, 3, 11. We also call them domain and range of this function. I can call it like f or g or h. That's the name of the function. I also made the example that we can show a function through a table. Instead of making a factory, we can make it to x and y. I label it x and y. You can label it a and b or whatever you like, as long as one of them should be independent and the other side should be dependent. For example, in this example, y will be depend to x, or in this factory, this 5 depends to 1, but 1 is independent. So I can write it 1, 2, 9, and 5, 3, 11. So in this video, I'm going to make two types of example about the way we show the function. So the third one will be, instead of making a table or factory, I can make it to set of the points, like a set of 1, 5, 2, 3, and 9, 11. So this is, I can call it f. Function f has a set of points 1 and 5, 2 and 3, 9 and 11. So the domain or the input of this will be 1, 2, and 9. And the range of this function will be 5, 3, and 11. Another way to show a function, I might give you guys a graph. So let's have another example. A graph. So before we go to graph, let me make another set of points, like function g gets 1, 2, 2, 8, 3, 5, and 4, 2. So in order to know if this is a function or not, we only look at the input. Input doesn't repeat, so this is a function. We can talk about domain and range. But instead of giving a set of points, I can give you guys a graph. I can give you guys a graph like this. So I'm calling this graph like h of x, y h of x. So this is x, which is the input to the factory, and the y here will be h. So inside of this graph, we have points, x and y. For example, each point has different x and y. How do we know that this h of x is a function or not? We cannot just look at all the value of x to see if it's repeated or not. What we do, we make a vertical line test. If the vertical line doesn't cross the graph more than one point, then this is a function. So passing the vertical line test, only you see this one intersection, so h of x will be a function. So let's have a question for you guys, or quiz. K of x is a graph like that. This is x, and this is k of x. X is independent, so it looks like x and k of x. There are millions points out here. I can list them on this and also list the value of y over there, which is not going to be possible because there's a lot of points. So how do we know that this graph is a function or not? We apply the vertical line test. So vertical line, any vertical line you make, it crosses at one point. So therefore k of x is a function. Now that is a function, there should be a domain and range for this. What is a domain? Domain is always value of x. And this example, for example, I'm going to put here -10 and here is 20. This much will be the domain of k of x. How do we write it? Definitely we are not able to just write -10, -9.999 and list all of them till 20. We need to use inequality. Inequality will be x such that x is less than 20, greater than equal to -10. So this will be the domain, and the range will be from here to there. We can write same inequality like range is y such that y is between, I'm going to just call it 3 and 11. More than 3, greater than 11. We will work on a set notation in one of the sections, but for now I want you guys to have this in your mind that mostly in this course you will see a graph. You have to find the domain of the graph if that's a function, or the range, and there are more questions about the graph that you will see to analyze it. All right, bye.